right, so hopefully after you graph those, you got something here. So go ahead and check your answers. So notice this first row, these lemniscents all had the kind of loop, okay? And if you're kind of looking, you'll notice that the ones that had a sine, those were kind of up, down, and the ones that had a cosine were kind of to the side more. In this row here, you have, these are called cardioids, okay? They're the shape of a heart. Notice that that little tip of the heart there goes right to the origin. And again, if it was sine, you're thinking up, down. If it was cosine, it was to the side. And I could have made one of these go flip the other way if you kind of mess with what's positive and what's negative. And then this last row, this was kind of the weird row. These all kind of had like this flat edge. It was like a circle with a flat edge, circle with flat edge. And then this one almost had like a little dimple. It wasn't a cardioid because it did not come to the origin, but it kind of had like this little dimple that was there. So you're like, well, what patterns do you recognize? What do you notice? What conclusions can you draw that makes this useful? So we already decided that we're going to get these kind of shapes when you're going to have this plus or minus sign in there. Okay? So when you're doing this, the lemniscents containing the sign will be mostly, okay, sorry, will be mostly above the horizontal axis if the sign between A and B is positive, okay, and mostly below if the sign is negative. Notice all the ones with a cosine, those are going to be to the side, so it's going to be to the right of the y-axis if the sign is positive, and to the left if it was negative, okay? So we can kind of use that. Now this is the important part. It's that ratio of A to B. Remember, A is the number here, and B is always the thing with the sine or the cosine. So what you're actually doing here is dividing. So for A divided by B, if it was between 0 and 1, that's this first row here, right? You get 1/3, 1/2, right? So that when that ratio is a fraction between 0 and 1, that's how you get that loop. Versus the second row, if the ratio 2 divided by 2 is 1, 4 divided by -4, it's a -1, but the absolute value there. Like if this is a 1, okay, it looks like a heart. And again, the special name for that is called a cardioid. And then the last thing that we have to talk about is, well, what if that ratio is greater than 1? Well, when that ratio is greater than 1, that's going to be this third row. 2 divided by 1 is 2, right? This is 1.5. This is 2. This is, 5/3 is still bigger. So it looks almost like a circle, but it either has this small indent, this little dimple, or it'll actually kind of flatten out depending on how big that ratio, that end doesn't need to be there, that ratio is, okay? So that is how to graph a polar there. For the next part, all I want you to do here is write either the word circle, rose curve, or lemniscent. All you're doing here is categorizing. So for example, here I see this plus sign, so this one would be a lemniscent there, okay? And then there's a few where I just see like a 3 sine and then a theta, so this would be a circle. And I know that the roses have a coefficient with it, so this one here would be a rose. Okay, so you pause and go ahead and see if you can fill the rest of those in. So go ahead and check your answers there. Hopefully I got them all correct, and hopefully you got them all correct as well. And then the next thing we're going to do is we are going to convert between forms. So remember, we're used to things in our y equals, right? If I said y equals x squared, you would know that that's a parabola. You can think in terms of those rectangular coordinates. But for most of you, when I say, x equals r cos theta, you're like, I don't know what that means because the y or the x there was given first. So what we're going to do is we're going to actually spend a couple minutes kind of being able to convert between the forms. So say, you wanted to graph something and your calculator was in function mode, that's that rectangular, right? You can convert between and then be able to graph it, or you could just change the mode of your calculator, okay? So what you're going to do is you're going to use these 4 things as given. So you should recognize this equation. This is the equation for a circle, x squared plus y squared equals r squared. this formula should look pretty familiar to you. Okay, we used it in the last unit. I had it written as theta equals tan inverse y over x. That should be your directional angle formula right there. That should look familiar. And these ones are kind of new, but they actually, you can derive them from your unit circle. That's where they come from. And all you're going to do is basically plug in. So it says convert the following equations to polar form. So remember, polar form is r equals something, right? It has r's and thetas, and it does not have any x's or y's. So I need to get rid of this y. Well, what do you see up here that allows me to get rid of a y or replace a y that has r's and thetas? It would be this formula right here. So instead of a y, I'm just going to write r sine theta equals 4. And we saw that when we hit the y equals button on our calculator when we were in polar form, it was an r. So we can get r by itself, and we could say r equals 4 divided by sine theta. And let's just say that this was a multiple choice test, right? You go and you look and, oh no, that answer choice is not there. So one sneaky thing that someone might do is they may rewrite it like this, 4 cosecant theta. And you could do that because this is mathematically equivalent to 4 over 1 times 1 over sine, right? And what do we know that 1 over sine is? Well, 1 over sine is cosecant, so that's just 4 times cosecant. So that's kind of a little trick that you might see happen there. Okay, so here, x squared plus y squared, it says that I can replace that with r squared equals 25. And we would just say r equals plus or minus the square root of 25, which equals 5. So this is simply a circle with a radius of 5. And you should know that from, in algebra when you had to graph circles. This is a circle centered at the origin with a radius of 5. So if I was in polar mode, I could type that into my calculator. There is a disadvantage here if you were trying to graph this equation in your calculator, because your calculator wouldn't be able to graph that. You'd have to solve it for y first before. So that's kind of a limitation, and that's why polar, can be kind of handy, because your calculator would be able to graph that just as it is. So remember, in math, it's never enough to be able to do something. You have to be able to go backwards. So now, instead of going from rectangular to polar, we're going to go from polar. I'm going to give you polar, and I want my answer, instead of having r's and thetas, I want my answer to have x's and y's. So what I would do here is I'd say, all right, well, r sine theta, that's right there. R sine theta is y. So this is simply the line y equals 3. And you're done. It's that simple. Okay. Here, r equals 2 cosine theta. Well, r cos theta, I can replace over there, so you can go ahead and replace that. But you're like, wait a minute, I need the r next to there. So one of the things that you might need to do is multiply both sides by r. So you get r squared equals 2 r cos theta. I wasn't able to just straight replace, because notice this wasn't an r cos theta like it was over here where I could just straight replace. Here, this needed an r so that I could use it to replace with this. Now I have an r cos theta, and I can replace that with an x. This 2 just comes down for the ride. Equals, and now I have this r squared. Well, we know that r squared is x squared plus y squared. So you could leave your answer like this, x squared plus y squared equals 2x. Because now I am in rectangular form, I have x's and y's, and I do not have any more r's or thetas. Okay, that kind of concludes this lesson on polar coordinates. So you do have a one-page homework kind of attached, so you can use your notes. I would definitely recommend using your calculator to help you sketch the graph while you're in class, so use the calculator wisely. You don't have to use the calculator for anything, but if you feel like you need it to kind of get an idea of those polar graphs, then you can go ahead. So this is the homework assignment that you should be working on.